Hello everyone, and welcome to the third and final in the series of webinars that BHR Group is running on the theme of engineering innovation. In this series, we're sharing some of the things that we have learned over the years while helping customers conceive and develop what they expect will be a successful engineering innovation development program. In today's webinar, we will be focusing on some of the challenges that you may experience during product qualification and customer acceptance, and offer some advice on how to meet them. I've said before that product innovation can be a long and sometimes frustrating process, and so even at this stage there remain opportunities and dangers. So today is about getting over the finish line, but it's also about looking beyond the finish line and what you need to do now to be in a stronger position to support your product when in service. If you attended our previous webinars, you will know that innovation is a topic that's close to our hearts. We know that it is one of the ways to continuously improve your products and processes so that you can address emerging customer and regulatory needs and so remain competitive. Innovation done well is one way that you can do this. If you're joining us for the first time and want to know more about what we presented previously, then request a link in the chat and we will send it to you when it is available or when the other two webinars are available as well. Finally, a really quick reminder of what we mean by engineering innovation in the context of these webinars, and that is a new idea that adds or creates value to a product or process. Again, for a more complete description, visit our previous webinars. So on to today's agenda. We're going to be here for about 30 minutes, starting with me, setting the context and presenting a three-step guide on the things that we have learned. These steps are not exhaustive, but a snapshot of advice and learnings that we even have to use ourselves. That'll be followed by my colleague Mark presenting a case study and talking about the experiences and learnings that we and our customers have gained. But most importantly, for you and us to get most out of today, we'd really like to hear from you during either the presentations by using the chat function or in the Q&A sessions at the end. Next, some introductions. As Kate said, I'm Jerry McNulty, that's me on the left, and I am a business development manager responsible for developing relationships with key customers across the nuclear, renewable and defence sectors. I'm joined by Mark Fairhurst, shown in the middle, who is one of our senior consultants and a specialist in high pressure engineering and fluid power systems. Mark has been involved in many product development programs, providing valuable expert engineering consultancy advice, balanced with pragmatism that really have helped our customers turn concepts into viable engineering solutions and, even more importantly, compelling business advantages for you. Mark will present a case study from which we hope you will gain some valuable insights. In the background, keeping us under control and managing the chats is Kate Goldberg. So my thanks both to Mark and Kate for working with me today. But also, as this is the final webinar, a big thank you to all of you who have listened into and contributed to these webinars. We really hope that you've got some value from them. If you want to find out more about any of the topics that we have presented or more about BHR, then please feel free to get in touch. Next up, a short reminder of where BHR Group fits into the engineering innovation process and why we are able to talk on this topic from a position of some authority. We're a privately owned specialist engineering consultancy based here in the UK. Our experience is in the application of fluids engineering to solve problems for industry, which we've been doing since the 1940s. Fluids engineering crosses most, if not all, engineering disciplines, and so we're in a really good position for working for many different types of industrial sectors, each with their own needs, regulations, and so forth. This breadth of customers gives us a great opportunity to understand various engineering and business demands, and so adapt our know-how in a safe and effective way to meet them. As experts, we see that the greatest benefit we can offer you is to understand, quantify and mitigate engineering risks in your business. And we do this in a number of ways, which include providing expert-led advice and insight, engineering design studies, in-house R&D services and specialist test facilities. This allows us to develop, test and adapt innovative products from lab to near full-scale demonstrators. I hope that this gives you some appreciation of what we do and gives you confidence that we know what we're talking about. Let's now look at some of the things that we have learned and we hope will help you improve your chances of gaining customer acceptance and building that all-important long-term relationship. In our experience, customer acceptance falls into two broad categories. The first of which is meeting acceptance criteria, which are a set of well-defined and unambiguous targets for the performance, features, service requirements, and so on for the product. The second is around meeting customers' expectations and unmet needs, which might be less tangible and therefore less easy to define. As we and you work in engineering businesses, well, these are all driven by the provision and interpretation of specifications. And so you'd think that the second criterion would be less of a concern. But even in our businesses, there can be pitfalls around customer expectations that we need to be aware of. And also, before I forget, another point is that product acceptance is a two-way street. And at this stage, or even after product launch, the supplier could decide to withdraw from the market. However, I'm getting a little bit ahead of myself, so let's start by looking at some of the engineering-led requirements for customer acceptance. Proving that your product is what the customer wants brings a host of different interests into play. On the one hand, you have the interest of the buyer, operations personnel, maintenance personnel, and so on. And on the other side, you've got the supplier, where your interests are in cost engineering, manufacturing assembly, your after-sales support, and so on. So for customer acceptance, the abilities you will need to have or to demonstrate include things like operability or interoperability, reliability, maintainability, repeatability, manufacturability, and so on. Today, I'm going to look at just three of these. Now, this may not be the first thing you'd consider for customer acceptance, but one reason innovation can fail at the final hurdle is that we overpromise and underdeliver. This can lead to the product failing in service or being withdrawn from service, so it's something you need to consider as part of the customer acceptance process for an innovation product or process. Sadly, we know of customers who have wasted money on prototypes, should I say, that are useless because they're impossible or prohibitively expensive to manufacture. So you need to be considering manufacturing limitations and costs from the word go. At the same time, you as a manufacturer rather than as an innovator now need to know what your minimum viable product is, as this is a product you can create for minimum cost and least risk. When you know this, you're able to understand your production costs and the time as you're focusing your energies only on the features that are most necessary. And next, at BHR we work for OEMs and end users that require evidence of equipment lifetime performance in the operating environment. And for an innovative product, this is a challenge. Now, there are many advanced tools and methods for fine-tuning the reliability of your product, but the thing is that most innovators are startups and don't have access to them or to the test beds used to generate data on which these models are built. So our advice to you as an innovator would be to spend your energy to fully understand the reliability requirements of your prospective customer or customer sector and look for organizations that can help you generate the data, processes, and so on that will support getting a better understanding of reliability. Even for companies with these tools or test facilities, one of the common stumbling blocks that we come across is that there might not be any suitable lifetime data for your new product. And of course, you don't have the time to wait for obtaining operational data to show reliability. One of the techniques that we've found that helps is accelerated testing. However, accelerated testing strategy you employ must be carefully designed to fit the product. For the kind of qualification work that we at BHR do, accelerated testing is about collecting quantifiable data and typically involves testing either under the equivalent environmental conditions and fluids or using simulants that can be scaled up to the application environment. Our work has shown that a good quantitative accelerated test can quickly reveal the failure modes that will occur under normal operational use, but not introduce failure modes that will never be encountered in real life situations. You will hear from Mark shortly about the extent of reliability testing data that we had to collect in the case study that he's going to present. But what you won't hear, and what was also important for this case study, was the maintenance requirements of the product. And so I'm going to touch on that right now in a more general sense as our final ability that we're going to look at. Some of the most significant aspects of maintenance are in the skills and knowledge of your maintenance team, the quality of spare parts and materials, length of maintenance intervals, and skills and knowledge of the maintenance manager. Our experience is that this is mainly a people-driven process that you need to be embedded into. And again, our experience is that this also needs to be part of the customer acceptance process, especially for new products where, as I said earlier, you have limited normal use data to lean on. You need to know if the equipment is performing as expected, but sometimes, as this is a given, it can get less attention than failures, but you really need this data. Another thing, as your innovation might require a new operation or maintenance process, you will also need to know that they're being done correctly, because if done wrongly, it could show up as a product failure. And so your interpretation of maintenance data could be wrong. So to summarize, you need to get to the facts, and so stay close to the customer, as feedback from their maintenance people is very, very valuable, especially when you're just bedding in your innovation into their processes. When we decided to put this series together, we started by talking to some customers and also thought about some of the products that made it onto the market that we've been associated with. We did this to remind ourselves of the motivations that we and our customers had for innovating in the first place, and also to understand why some processes and innovations succeeded while others didn't. The picture here is just some of the products that we've helped develop, and from this and other developments, the three main reasons why customers decided to innovate in the first place were: one, competitive pressure. The competitors have done something that is eating into their share of the market, and so change has been forced upon them. Number two, emerging market opportunities. This is a space where smaller, agile innovators tend to operate. And as a kind of footnote, most of the products where we helped customers in this space were subsequently bought by larger businesses, although developed by smaller companies. Maybe this is a reflection of big industry not recognizing or taking the opportunity to innovate in the first place. And the third reason is really due to regulatory changes or standards and likes. Our analysis, which we'll come on to, shows that there is actually a case for doing nothing until forced to do so. And so we really think that you need to be an agent for change here, because the first thing is the sense is if it ain't broke, don't fix it. So I've also been talking to customers and discussed why uptake of innovation can fail. Some of the sectors for the innovations that I have just shown were for application environments where the consequences of product failure is not acceptable. Linked with this, these businesses, to be a success in the first place, work within stringent engineering standards and in regulatory frameworks. And so these businesses have already demonstrated a successful track record and experience and rigorous and robust processes and suitably qualified, experienced personnel for running them. If we put this together, we can see that BHR typically works with customers that are likely to be conservative and culturally and structurally slow to change. So they have business critical demands which are based on experience and proven processes. These understandably make it difficult for either an internal innovation program or outside provider to bring meaningful and long-lasting innovation unless they are supported by change from within. Our experience is that for innovation to be successful, it must be embedded across all processes and people that are affected by or who can affect the uptake of this change. So it needs to be given the same attention as processes and methods that have already made your business a success. And under the other theme of agent for change, our opinion is that we think all innovation should be thought of as a movement and not a product or a campaign. Movements usually involve changing people's minds over long periods of time, while a campaign is an action to achieve a goal, which is usually quite short-lived. In our businesses, many innovations take years to get into production. And so really here's a great opportunity to preempt many of the obstacles to change that you may face. Now, as a technology provider on the outside looking in, this can often be frustrating as there is little that BHR can do to directly address this change management. But there are things that we can do in supporting you in things like toolbox talks, a great way to learn about experiences of your wider stakeholders and share ideas during the product development stage, and also this helps shape the product. It can also be a great way to get some early buy-in. Now, as new products can typically take years before they're adopted, there's also a case for bringing a new product, even the idea of innovation, into the classroom. We've seen some of the most successful innovations being embedded into training and coaching programs, or even introduced as standard operating procedures during inductions and retraining of employees. So I'd ask you to ask yourself, why does Yamaha give pianos for free to schools? Is it in their words on their website to promote the spread and development of music culture, or could it be to sell pianos to future consumers? Smart move in my view. In our industry, introducing innovation is a long game, and so it's good to view it as a movement and not an isolated solution. So while I've got Mark Cavendish winning yet another stage of the tour on screen, let's enjoy the ride. Congratulations, you've crossed that finish line. But you can't relax because the next race is about to begin, and it's a different race. So if the innovation process was like the Grand National, a one-off race with lots of hurdles and that long run to the finish line, then continued success is like the Tour de France. It's a race where the competition is now looking at you and looking to exploit your every weakness. So you need to be ready to burn off the opposition day in and day out, because even after you get customer acceptance, you know that your competitors are going to react. So, and my final point is a short one, but an important one. We all know that you need a little bit of luck to succeed in business, as developing new products is never easy. But you need to earn your luck. The pictures you see here are a true story about how you can earn your luck. It's true because I was involved in some small way in this development. You can see that we've got some firefighters cutting into roofs using axes and saws to make holes. Now, they make these holes so that the smoke and the heat can be removed quickly, so that when the firefighters enter the building by other means, they can get the fire under control quicker. Anyway, a company that provides ventilation systems for Swedish firefighters saw a demo of our remotely operated water jet cutting system. This was for a totally unrelated application, but he thought that it could be a safer way to cut into these composite roof structures. So he talked to us and we designed a template to automatically cut a circular hole. And we took this template and our portable water jet cutting system to a fire training school in the south of Sweden. The equipment worked well, cutting a really nice, neat hole in the roof when there's a fire running below. The only problem was that when the firefighters went into the building to control the fire, it had already been doused. We realised that not only had the water jet cutting tool cut a hole in the roof, but in the process, this fine water mist had suppressed quite a big fire. This was because water droplets having a larger surface area cool fires more efficiently than conventional fire hoses. That bit of luck saw the development of an innovative firefighting technique and product called Coolfire. So a really good example of earned luck. However, this so-called luck comprised of an OEM supplier who had been in the business of ventilation systems for many years and intimately understood their customers' needs, together with ourselves, a product development company with an almost ready-made engineering solution and lots of design know-how that we could adapt for a different application. Yet even with these clear benefits and capabilities, it took years and many demonstrations and product refinements before Coolfire gained acceptance. But with hard work, ambition, good habits, you might find yourself in the right place at the right time to get lucky. So in summary, build your networks, keep on top of the data, and finally, good luck for tonight's football. With that from me, I'll hand over to Mark to present today's case study.
Thank you, Jerry. I'm going to talk about Diajet ACE as an example of what it takes to gain customer acceptance of a product through a rigorous testing program. The equipment was for a military application across many theatres, and as such had to be capable of operating in frozen lands to desert and from high altitude to subsea. It was subject to possibly the most stringent testing, reliability, handling, ergonomics and safety requirements to be found anywhere. These requirements are set against a background where issues such as magnetic influence, rapid deployment, including helicopter lifting, electromagnetic interference, and battlefield conditions all need to be taken into account. I will describe what ACE is, as most people will not be familiar with the product. I will describe how a set of customer requirements led to a set of tests with clearly defined pass and fail criteria. I will then discuss some of the tests we did on the ACE product to gain customer acceptance. ACE stands for Abrasive Cutting Equipment and is one of the products in our range of Diajet cutting systems. BHR built nearly 40 ACE systems for the UK MOD for explosives ordnance disposal, which essentially means making safe and removing explosives from bombs. The system relies on the cold cutting ability of abrasive water jets and is something that we've worked on for the past 40 years. The particular requirements for the ACE system were that it should be able to operate at a safe distance from the target, be able to cut castings, fuses, and be able to wash out the explosives. It also needed to be highly portable and transportable. The ACE system was supplied as a kit sitting on a NATO pallet that could be towed on a military quarter-ton trailer. On the pallet was everything you needed in man-portable units, from the water supply module, the pump module, the abrasive feed unit, and the manipulator and hoses and cables to run up to 500 meters away. The system could be operated from the safety of the trailer, while the manipulator was of a flexible design to cater for just about every conceivable configuration of target and location. ACE is a good case study in that it demonstrates the many varied categories that need to be tested and satisfied in order to ultimately meet customer approval. The pass and fail criteria need to be measurable, unambiguous, and accepted by all parties at the outset. As we have discussed in previous seminars in this series, various building blocks can be developed and tested independently, but they finally have to come together to be tested as a system. For example, the manipulator will behave differently when the nozzle is attached to it, as the weight of the hose can slow it down if there is insufficient drive power. Specific targets can be set for this. The jet needs to be able to cut a wide variety and thickness of materials at a rate that is constant and predictable. And again, specific targets can be set for this. When it comes to deployability, then this can be less clearly defined. And so we had to come up with targets around battlefield mission success. Physical signatures relate to noise and electromagnetic interference, for example, and are based around mobile military equipment standards. Last, but certainly not least, is safety standards, and a specific example is the Pressurized Equipment Directive, with the need for pressure testing of components and systems. So many times we see testing being left to the end and taken for granted, with little thought and little budget left. There is usually no margin for failure or fix. In actual fact, a good technical specification at the outset will set out the testing requirements and prevent later confusion. In this case, the reliability criteria was specified in the contract, and so this certainly helped to remove any doubt as to what was to be expected of the equipment. These are some examples of the reliability acceptance criteria based upon simulated battlefield missions, with a requirement for 95% without a mission critical failure and 75% without unscheduled maintenance. A mission critical failure is defined as any incident or failure which cannot be repaired by the operator in 30 minutes and which prevents the user carrying out a successful mission. A basic failure is defined as any unsatisfactory equipment condition that requires unscheduled maintenance action to restore the equipment to its serviceable standard. This is a good example of how it is possible to define tests to meet criteria that are measurable and unambiguous. As I said earlier, agreeing these with the customer at the outset can be a real benefit. The tests we did on ACE included EMC testing, environmental testing from -15 degrees to +55 degrees, and one test in particular meant we had to have a 10mm ice coating on the equipment and it still be able to operate. We did vibration testing from 1 to 10 kHz and a drop test from a 0.7 meter height. Altitude testing had to be done to 3.5 kilometers. We also had to do helicopter lift trials. We did non-magnetic testing. We did reliability qualification trials, which were extensive here at BHR. We did demo trials and we did user trials. BHR outsourced some of the testing, and there's no shame in admitting that it's just not sensible for us to set up facilities where they are available for us to rent from others. This was certainly the case with the electromagnetic compatibility and non-magnetic and environmental testing. It was also the case of the helicopter drop tests, because even though we're situated on an airfield here at Cranfield, others were certainly better placed to do that type of test than we are. We were, however, able to do all the reliability trials in-house, using our equipment reeled out over a 500-meter distance with the manipulator and a range of test targets with simulated explosives. This ironed out any bugs in the equipment prior to live munitions testing at various MOD locations. The good thing about these trials is that the customer was able to witness the trials and be trained in the use of the equipment while building up the confidence ahead of live munitions trials. During the trials, we recorded all the faults and observations, and correcting these is essential before moving forward. And so you need to keep a fault and observations register during the testing. It is regular practice when undergoing military equipment evaluation to be required to attend military firing ranges, with trials equipment and personnel being required to perform a wide range of control proving trials. The trust, respect, and acceptance of the military users can only be won by producing equipment and methodologies that clearly fit their needs, the conditions in which they work, and the way in which they work. During the ACE program, nearly 40 types of explosive device were successfully cut with the ACE system during the trials at these various MOD locations throughout the UK. Customer acceptance came from rigorous testing to predefined criteria using a mixture of military standards and performance criteria clearly defined within the original contract. So in summary, getting customer acceptance for your product comes from proving it meets the specifications set out in the contract, but just as importantly is actually what they want. Things are a lot easier if this specification is detailed, as it allows a clear pass and fail criteria to be set and agreed at the outset. This usually involves proof of meeting regulatory standards, as well as a set of customized performance and reliability criteria. Make sure you keep a list of faults and observations, as you and your customer can tick them off as you go. Hopefully the list gets shorter, so in the end you get a pass.